In this demonstration, you will learn how to restrict access to Azure AI services and also to the Azure API Management through using private link services and private endpoint. So we'll have multiple Azure AI services instances deployed in multiple regions like what we see here, and all of them, they will have their public endpoint disabled, and the only way to access those services is through private endpoint. So each one of these instances will have a private endpoint injected into a virtual network or into a specific subnet, and then the Azure API Management will be able to access those private endpoints, because here the Azure API Management will be injected into a virtual network, so it would have access to these private endpoints. And then the Azure API Management itself will have its own public IP address disabled, or the public network traffic will be disabled, and the only way to access it is through a private endpoint. And here we want to expose that Azure API Management publicly through an Azure Front Door service that provides security features like WAF and global reach, as it's using global point of presence. So then the client applications will connect through the Azure Front Door, and then the traffic will be routed to the Azure API Management, and from there it will be redirected to the multiple instances through the mechanism of the load balancing, where we can route the traffic by priority or by weight. So that's for the global exposition. Now, if you want to access that Azure API Management from within the virtual network, let's say here we have an Azure virtual machine from the same VNet. If that VM wants to access the API Management, actually it cannot access it through this private endpoint that is used by Front Door, because this private endpoint actually will live within a Microsoft managed virtual network. So we need to create a second private endpoint for the Azure API Management, and that private endpoint will be injected into the subnet where we have that workload. In our case, that's the Azure VM, and then the Azure VM will be able to connect to the API Management privately using that private endpoint. And because here we are using private endpoints for the AI services and for the API Management, so we need to be able to resolve privately or from within this virtual network the different private DNS zones that will be defined for all of these services, for the Azure API Management and also for the AI services. Follow me next for a demonstration to deploy all of these services and to test the private connectivity. For the demonstration of the private connectivity, we'll be using a lab available within this GitHub repository, Azure Samples AI Gateway, and that is the lab called Private Connectivity. Within this GitHub repo, actually, you will find multiple samples and multiple demonstrations for how to use the different features available within Azure API Management, the AI Gateway. And the one that we'll be focusing on today is going to be the Private Connectivity Lab, which have all the files required in right here. And to make things easier here, actually, we'll be using a Python notebook, this file right here, and we'll run the different steps and the different instructions within this Python notebook. The easiest way to work with this demonstration is to go to clone this GitHub repository into your local machine, open it in VS Code, and then navigate to the Private Connectivity Lab, where here you will find the Private Connectivity Python notebook, and this is the file containing all the instructions. So let's start here first by creating the different Azure resources. For that, here we'll be relying on Bicep in order to do that. And the first step would be here to set up some environment variables, or some variables actually, like what we have here: the name of the resource group, the name of the Bicep deployment, the location of the resource group, and the SQ of API Management, where here we are using standard v2. And then we are specifying here in this array the different instances of Azure AI services with their locations and their capacity. Then we are specifying the deployment name for the OpenAI models. Here we are using the model GPT-4o, but this should be compatible with any OpenAI model. And then we are specifying the model version, the capacity, the model SQ, and the API version. Once all of these variables are initialized successfully, you can do this actually by clicking this play or this execute button from here. That will run this Python code and will output the success message on here. Once that's done, we just move to the next part, which is here verifying the Azure CLI. So as we want to deploy resources into Azure, we need to be connected to Azure. So for that here, we need to make sure that we are using the right or the correct Azure subscription. For that, we show here the current username, the tenant ID, and the subscription ID. You check if that's correct, and then you move to the next part, which is here creating the deployment using Bicep. So this is the main part of this demonstration where we create all of these resources. So to run the Bicep file, we first need to specify a Bicep parameters. So for that, we create the parameters file, which is a JSON file that will contain the key value pairs. So you will have the key value for the APIM SQ name, the OpenAI config, and some other parameters related to the properties of the OpenAI. And then we have here APIM public network access, which is set to enabled at first, but we'll see why we do this later. And then next we'll go here to write those different variables into a params.json file. So we write it using json.dumps. We write it within the file params.json. So if I open that file and format it, we can see here the content containing the different parameters, APIM, SQ, value, and the OpenAI config that contains the different AI services with their locations, and then the properties related to the AI services and the public exposure of the APIM service. Once that's done, now we are ready to run the Bicep code. So for that here, we'll be using the command iz deployment group create, then specifying the deployment name, the name of the resource group, the template file, which is the main Bicep file, and then the parameters, which is the params.json file. This will take about 6 minutes to run. I have actually run it before starting this demonstration. So you just need to click again the execute button right here, wait for about 6 minutes, and then you should see all the resources created successfully. And at the end here, you should see the ARM output file that contains all the resources that have been created. Once that's done, now you can move to your Azure portal and check within the resource group that you have specified all the resources that should be created. So here you can see actually 26 resources have been created. The most important one here is the Azure API Management, and also the Front Door service and the Azure AI services instances. And here we have actually 3 instances that lives within different locations. So you can see East US, Front Central, and West US. And each one of these services actually, if I navigate to the networking section, you should see that here the public access is disabled. This means that we cannot access it from a public network or a resource or an application that is not within the same network of within the Azure AI services network. And the only way to access it is through a private endpoint. So here we have a private endpoint that was created that will provide access to this Azure AI service. So each one of the AI services would have its own private endpoint and its own network interface. To resolve access or to reserve DNS access for these AI services, we have created the 3 private DNS zones for cognitiveservices.azure.com, privatelink.openaiazure.com, and privatelink.services.ai.azure.com. Each one of these private DNS zones will have the 3 A records for the 3 private endpoints, pointing to the private IP address for each of these private endpoints. And each one, of course, is linked to the virtual network where we have the Azure API Management. So that configuration is described within this Bicep template, where here we find the creation of the virtual network, the different subnets, and then the cognitive services, where we create actually 3 Azure AI services. Each one will have the public network access disabled, and a model will be created in each one of these AI services. And then we specify the role. So here we set the role OpenAI user role for the managed or for the APIM managed identity to be able to access that Azure AI services. And then we create the private endpoint using Bicep right here. We map that, or we inject that private endpoint into the subnet for AI services. And then we define the private DNS zones. We link it to the virtual network, and then we add the A records through the DNS group. Great. After that, we create the Azure API Management that is described within this bicep block code. So API Management in our case will use the standard v2. It will have virtual network type set to external because as per today, internal is not accepted. And the public network access will be at first public, and it's injected into the subnet, a specific subnet for APIM. And it's using a system assigned managed identity. Let's check its configuration. So here, if I go back to the resource group, then navigate to the Azure APIM, I would see here the resource, and I can see also from the network section right here, the public network access is set to enabled, but actually we'll go to disabled later. And you can see here the two private endpoints. Why we have two private endpoints? Actually, one will be used by the Azure Front Door and another one will be used by the Azure Virtual Machine to connect from within the same VNet. You can see that here one of the private endpoints is in pending state. We'll see later how we can approve it. But now let's continue to see the configuration of the Azure API Management. So we'll navigate to the managed identities, where here we can see the use system assigned managed identity is enabled, and within the Azure role assignment, you would see 3 role assignments for the different instances of the Azure AI services. Great. Now within the APIM, we want to connect to Azure AI services, so we'll do that through the APIs. So from here you can see the API that have been used from here, which are the API coming from Azure OpenAI, and that was configured again using the Azure bicep code right here, where we have the definition of that API, activation of the subscription key, and also an API policy that is specified right here that will go to manage the authentication into the Azure AI services, and also it will set up the backend service so that the APIM can route the traffic to the 3 instances of the Azure AI services. And then here we are creating a private endpoint for the APIM, and actually that's the private endpoint that is represented right here within this architecture diagram that will be used by the Azure VM. With that private endpoint, we would have the private DNS zone and a link to the VNet. And then here comes the part where we create the Azure Front Door in order to expose publicly the access to the Azure API Management. So Azure Front Door will be accessible publicly on the internet, and it will be able to access privately the Azure API Management. How that works? Actually, here we expose the Azure API Management through a private endpoint or a managed private endpoint that will live within a Microsoft managed virtual network, and Azure Front Door, through its origin configuration, it will be able to connect to that Microsoft managed virtual network, and thus it will be able to access that private endpoint for accessing Azure API Management. That configuration is described within this bicep template right here, where we have the front door origin section, a shared private link resource, where here we specify that we want to use private link to connect to the Azure API APIM service, and then we add a route to the Azure APIM. We can view that configuration if we navigate to the Azure Front Door. Then we go to the origin groups, select our origin group right here, and from this configuration you should see here that we have an origin host name that is the FQDN of the Azure API Management. So within here you have the origin type is Azure API Management, and then the origin host header and host name are the FQDN of the API Management. We'll be able to connect through HTTP and also HTTPS, and from here we are enabling private link to connect front door to APIM. So this means that a private endpoint will be created within the region France Central in my case here, and that uses the target sub resource, the type gateway. And we are specifying here a request message, please validate the private endpoint connection. Why is that? Because remember here when we have seen the APIM networking section, we have seen that we have actually 2 private endpoints. One of them is pending connection. So this is the private endpoint coming from the Azure Front Door. Actually, it should be approved on the Azure APIM side. How to do that? So actually there are 2 solutions. Either we navigate here to the private link services, and then from here navigate to pending connections, and then you should see a pending connection for the Azure APIM, and you just here check it and then click approve. I'll do that here from the Azure portal, and I click yes to approve this connection, and this will take 2 to 3 minutes. So that's solution 1 to approve the front door private link connection to APIM. The solution number 2 is using the AZ command line, where you go just to list the private or the private link connections that are in pending state, and then you get its PLS ID, and then you run the command AZ network private endpoint connection approve, and then you pass in the ID the connection ID. The next step here is to go to disable the APIM public network access. Here within the network section of the Azure API Management, you can check that the public network access when it's when the APIM was created is set to enabled. This is, at least until today, is a limitation for APIM in standard v2, where it should be created with the public network access set to enabled, and then when you have private endpoints, so then you can disable it. And that's what I'm gonna do right here using the Azure portal. So I click on enable, and then I set disable and click save, and then the operation is done. So that's one way to disable the public network access. If you want to automate that step, then you can just use this block of code where we'll go to the bicep parameters. Remember, within the bicep parameters we have a parameter to set up the APIM public network access, and that will change the public network access right here. So at first that parameter was enabled. Now just go to change its value to disabled, update the value within the params.json file, and then run again the AZ deployment group create, and bicep will update that value within the APIM. Next, we'll go to get the deployment outputs. So when we deploy this bicep template, actually at the end we'll get here some outputs right here, like the APIM resource ID, the gateway URL for the APIM, the subscription key that will be used in order to authenticate to the APIM, and the front door endpoint. We'll get those values from the deployment output. So I just run this Python code that will go to fetch those values from the output, and here we get all of these values. Great, so now we are ready to go to test access to the Azure APIM through the Azure Front Door from outside the virtual network and also from inside the virtual network, and that's what we'll do in the next video. Now that we have the front door endpoint, the APIM gateway, FQDN, and also the APIM subscription key, we are ready to go to test access to the Azure AI services through front door and APIM. Let's start first by direct HTTP call through the front door. So for that, we'll use the requests Python library in order to create a post request that will send this message specifying the system and the user input. We'll send that request to the URL, which is the URL from the front door endpoint. Then we'll get the response. We'll parse that JSON response, and then we'll output the response from the LLM model. Let's try this code. Here the call was done successfully, and here we get a response status code 200. It's success, and here I get the response to my user query. Great, so here we have tested this client connecting to the Azure Front Door. Now let's test access directly to the Azure APIM. So as we said, Azure APIM is not exposed publicly through the internet. It's exposed only internally through the private endpoint. So this client right here cannot connect directly to the Azure APIM. Let's confirm that. So here I'll go just to rerun the same method that here I have called it call API, but instead of passing the front door endpoint, I'll go to pass the gateway URL or the APIM URL. Let's run that. That call will fail with status code 403, and here it's telling me that the request originated from client IP address from public network access on the Azure API Management is disabled. To connect to that Azure API Management, I should use the private endpoint from inside the virtual network. Great! So let's now try to connect to the API Management through the private or through the virtual network. So here within the bicep template, we have created an Azure virtual machine and also a Bastion resource. So here we have the block that creates the virtual machine. It's an Ubuntu virtual machine. And then we have the Bastion host that uses developer SQ. It means it's free, and that will give me access to my virtual machine without using a public IP address. So to test this connectivity right here, I'll go inside the Azure virtual machine and run a curl command that will try to authenticate and connect to the Azure APIM. I could actually rerun this same code right here, or this same Python script within the VM, but that means that I will need to install Python and install all the required dependencies in order to run this code. So the easiest option would be to just run a curl command, because curl is already installed into my Linux virtual machine. And within this section, I provide the curl command, or I build the curl command that should be run. So I just specify here the APIM resource gateway URL, the name of the deployment for the model. I say the content type should be application/JSON, and then I specify the APIM subscription key to authenticate to the API management. And then within the data section, I specify here the messages that will be sent to the LLM model. The output of this would be this curl command. So I'll just go to copy this output, copy cell output right here. And then I'll go to the Azure portal where I have my Azure virtual machine that will act as a jump box, and we'll go to connect through Bastion to that VM. Here I'm using VM password. I specify the username, and these two values are hard-coded within the main bicep file right here. Of course, for the password, that's not a secure way. In real life, this should be secured. So I'll connect with that credentials to this Azure virtual machine. That will open a new tab in my browser and will give me SSH access to that Azure Linux virtual machine. And then here I'll just go to paste. So here I just paste the curl command with the different arguments. Run the command and just wait for the response. And here we get the response with success with the content that is written right here. And that was how to provide private connectivity for Azure AI services through a private Azure API Management to an Azure Front Door, and also to workloads within the same virtual network. Thank you.